Got it?
Why?
I don't know. So we got a right triangle, there's our rope. It says if the rope is hauled in at a rate of 4 feet per second.
That's the
Well, we need to define the sides of the triangle. What do you want to call this?
the bottom's X.
Bottom of the X, I like that.
The side's
Mine
Y.
is Z.
Yes.
I like that, Y. Z?
Yeah.
I'm gonna use R. I like R.
No.
Because it's the rope.
It's Z.
I'm using R. Whatever.
X Y R.
It says the queen of sass.
It's a rope. It's R.
You can be
Okay. So if the rope is hauled in at 4 feet per second, what is that telling me?
The R is DR. DT is 4
DRDT.
feet per second.
We're going positive this way?
Yeah.
Okay. 4 feet per second. How fast is the boat approaching? So when
So we're
ask,
finding DX DT.
what are we finding? DX DT. That would tell us how fast the boat is getting closer. When 25 feet of rope is out.
So X equals 25.
No. R equals 25.
Oh.
Or
That's the
Z,
problem
whatever you
wrong.
use. So there's what we know, there's what we're finding. What do we know?
Don't you know why too?
Yeah,
Don't we
Y
know
is
why?
7.
Yes.
Seven.
7
Y is a
feet.
constant.
Yeah, because that's not going to move.
So you don't have to.
So what's our equation going to be?
X squared plus 7 squared equals Z squared. R squared, sorry, I used Z.
Yep. And then
And the
derivative.
derivative.
2x dx dt plus
Zero.
0, so I don't even need that. Equals
2R.
2r.
dr.
dt.
Now you have to do Pythagorean theorem to find R.
DRD.
I mean X.
Yeah, notice we have an x in this, right? We need to know what x is. Well, we know r is 25 at this instant, y is 7, so can't we figure out what x is?
25.96.
No way it's longer than the hypotenuse.
Oh, you know why?
A squared plus b squared equals c squared. Yeah, you flipped those, didn't
I
you?
did, yeah. That's why it doesn't make sense.
So that's 25 squared.
200.
625, isn't it?
Yes.
625 equals 49.
Subtract 49.
So x squared is
576.
576, and the square root of 576.
Excuse me.
Calculator's not working.
24.
24 something?
24 even.
24 even?
Yeah.
24. So that tells us at the instant we're looking for, this is 24 feet. So now we know what to plug in there. We should know what to plug in there from. Oh no, that's what we're trying to find. We know R, we know dr dt. It's easy money now, right? 2 times 24 times dx dt equals 2 times 25 times dr dt was 4. So what's that, 200 divided by 48?
4.17.
What is it? 4.17?
4.17?
4.17
Feet per second.
feet per second. Seems wrong. I feel like that's wrong.
Why? Because we actually know what we were doing.
No. Because the boat's moving faster than the rope's getting pulled in.
That makes
Well,
sense. It's
duh,
momentum.
because if you jerk the rope,
It
it
just-
pulls it and then it keeps coming. You get me? Yes, I've tried this before.
But that doesn't apply here.
But like
If you pull the rope at a constant rate, is the boat going to move faster than your hand?
The
But
water.
if there's other boats at the bottom and there's waves and it's pushing it.
That's right. I mean, that's right. It just doesn't feel right.
Is
Once we get it right, he
What do you have in
usually
your
gets
answers?
right.
Or do you not have answers for these?
I found it. That's what I Simple. Whatever. Did you do it successfully at home by yourself?
No.
Yeah, I did, but I got that back
So
answer.
I didn't even know
Yeah, I
what
got
that
pretty far
was.
on number 2, but then I didn't know what to do.
When I flipped them, I still got the same answer though.
Deuce. Let's see, a rocket.
Look at my picture.
Better than the last rocket. They don't look like a pamphlet. No rocket has a
Oh,
rocket.
that. Why are you checking out my
Aw.
Why are you checking out my
It looks
tampon?
like an actual.
Why are you checking out my rocket?
The rocket is rising vertically at a rate of 5,400 miles.
Yeah, it does.
An observer on the ground is standing 20 miles from the rocket.
Think about my brain right now. I don't want to think about it. It's a spaceship.
There's the guy. That guy, this is not to scale because that guy is really tall.
Alright.
Right?
The ground's
If
X.
that's 5,000, oh wait. If that's 20 miles, that dude is like a mile tall. Anyway, he's looking up at the rocket. Hey, yeah, I think we've got a right triangle here.
The bottom's
He's 20
X.
miles away.
And the rocket is
Well,
40
we'll just
miles
call that
away.
X. We'll just call that Y.
Z.
Z. Okay, I don't even know if we're going to need it, but let's put it
I
there.
put C actually this time.
An observer on the ground is 20 miles from the rocket's launch
Second
point.
APC.
So at the time, we know X is 20 miles.
Y is 400.
How fast in radians per second is the angle of elevation between the ground and the observer's line of sight
So
of the
you're
rocket
finding theta.
increasing? So we're looking for, what are we trying to find?
D.
D theta over dt.
Yeah.
Theta dt when X is 20 and when the rocket is at an elevation of 40 miles.
Oh, I think I did that right.
Yes,
Because
because
it's
these are all with
derivative
respect to time.
time.
It's always I haven't found another one that's not.
Y equals 40.
When y equals 40.
And dy dt is 500 and
Oh yeah, the first sentence, as I say, I feel like we're missing something.
540 miles per
is
hour.
5,000.
dy dt, because it says it's rising vertically at
We can't see all of
5,000.
that correctly.
So there's everything we know. We just need to write the equation and do the derivative and plug the crap in.
First, you need to find
Tangent
your
of theta.
z.
Yeah, we don't need z.
Oh, you don't?
Wait, why didn't you scratch out 20 miles?
Oh, then why not?
Because I wanted it to be an x for when we wrote our equation. I guess that's not changing. So we could have just left it as 20. But I wasn't sure if the dude was going to walk backwards or what was going to happen. So I just put an x.
Well, you're gonna have to actually do the tangent of x over y, so it's easier if you keep it, because then you have to do the inside derivative of that, which is like x dy, y dx.
Okay. Yeah, as I say, we don't care about z. We've got everything over here is y and x. We're looking for theta, so can't we just do tangent?
Yeah.
It's not Pythagorean theorem here. It's tangent of theta equals
X over
opposite
y.
of
40 over
adjacent
20.
y over
Oh,
x.
that's what I meant.
Yeah.
Oh, that's where I think I went wrong.
You do.
So now you have two options for your derivative. You could just do the derivative of both sides and solve for d theta dt. Or you could do inverse tangent of both sides. Then it'll already be solved for theta, but your derivative will be a little different.
Wait,
You want to see both ways?
What's the easy?
I don't know. Do you know the derivative of tangent, or do you know the derivative of inverse tangent?
Tangent.
Neither? Then you're screwed.
well,
No.
I lost my favorite. I
Is it
did them all.
Do inverse tangents easier.
Yeah, inverse tangent.
Inverse tangent's
Yeah.
easier? I think regular tangent's easier myself. I would do the derivative of that. Huh? Like if you tried to do the derivative of that, do you know the derivative of tangent?
Hey, what's
Cosecant
dx?
squared.
Are we finding d? We don't have dx.
You see, you don't even know.
Yeah, I do. Watch.
Hey,
See, if I'm Brennan right now, I would be like, shh, I can't remember the derivative of tangent. But I'd go, psst, hey Shania, right? And then, so
I did that.
SST. I showed this in a video one time.
Oops.
Oh, yeah.
Mine's the key.
the derivative of tangent is secant. No, it's tangent.
Cosecant squared.
It's secant squared,
You sound
because I know this. And then you put the opposites of them underneath. What's the opposite of tangent? Cotangent. And then you put arrows to the middle. and that bottom one's negative. So like the derivative of cosecant is negative cosecant cotangent. Derivative of secant is secant tangent. Derivative of tangent, I go backwards, it's secant squared. Ooh, secant squared. This might be harder.
Do the inverse.
Let's just see what happens.
Mm.
So derivative of this
It might get
is
wet in the screw
secant
bubble.
Wait, can
squared.
you answer a question before you continue?
Yeah.
We don't have dx, dy, I mean dt.
dx dt, the dude's not moving, so we don't need it.
So it's zero. If you,
Zero.
if you don't have it, it's zero.
Well, just the guy's chilling. He's watching the rocket. He's not moving. And then over here, I'd have to do quotient rule, right? Did you do it this way, Brian, or the inverse tangent way?
I did both.
Good. So low, d high, minus
But I did cosecant, so I
high,
kind of need to change
d
that.
low. Am I right? It's secant squared, right? 'Cause
Yeah,
I'm-
you are right.
You were right.
I put some cosecant as well.
Oh, the other way is going to be easier. Yeah. Because this is. Ugh. How are we going to solve? Oh,
We're
I
not going
forgot.
to
I forgot d theta dt. Oops. Secant squared of theta
D theta dt.
d theta dt. Now it's not so bad.
Whoa.
So I'd have to plug in everything I know here, including I need to know what theta is.
63.43.
Yeah. So really, if I solve my d theta over dt will equal all of this. Divided by secant squared theta. So now I just gotta plug in all that stuff and I'll have my answer. Want to try the other way now?
But you don't have.
I'm not done. I just got to plug in
Like Shania said, you don't have dx dt, so it's
It's
just
zero.
It's zero.
Okay.
Is the answer? Do you have the answer?
Yeah,
Can you just give it to us?
54.
Oh, why? I didn't get that. Ow.
Minus 0.
I'm going to plug it on this stuff. X, let's see. Where's X is 20 times dy dt.
5400.
5400. Minus 0, right? Because that's just 0 times
Oh, that's
y.
where I went wrong.
Oh my
Over
gosh.
x
Negative 40
squared,
times 0 is 0, not 40.
400. All divided by the secant squared of, oops, I need theta. How do I get theta?
You find tangent of theta equals 40 over 20, which is the
Yeah,
tangent
we
of theta
know-
is 2 inverse tangent of 2.
We know x is 20, we know y is 40, so if we do a little right triangle trig here, 40 and 20, theta, tangent of theta equals 40 over 20. So the inverse tangent of both sides, what is it?
63.43.
Okay, here's the real question then. How do you do secant squared of 63.43?
Secant squared? It's the 1 over tangent squared.
Close.
Negative, I don't know.
It's 1 over cosine.
Oh.
So really
Oh,
this
that cotangent's
is
tangent.
1 over the cosine of 63.43.
So flip and multiply.
All squared.
I can't just put secant squared not in your calculator.
Nope. Calculator doesn't do secants.
So you have 108,000 over 200. Oh, no, it's 270 the answer. 270, I mean.
Oh my gosh.
I don't have that on there.
So now it's just a lot of calculator work. 20 times 54.
Yeah, the other way's a lot easier, dude.
270?
Divided by 400. 270 divided by that thing.
It really is.
We'll do it the other way too, don't worry.
Oh, sorry.
We'll have time.
I don't even know what way is the 2 ways.
One way is, so you have tangent of theta equals the whole x, right? So he just leaves it like that and does the derivative of both sides. The other way is solving for theta first, so then you would do
I
like
did not get
theta equals the inverse
Did you
tangent.
get 54?
No, you're still,
Two?
how I did it is like, so
Oh,
this is how you have
I'm
it,
in
like
radians.
this. Well, what I do is I solve for
We
theta.
did that.
to the inverse.
Did you tell me that
So
in
basically,
degrees?
do you wanna do the derivative of tangent, or would you rather do the
Bad,
inverse?
Brenna.
I don't know.
So then
I
I do
believed
the
you.
inverse to where you.
Wait, hold up.
equation,
Inverse tan, oh
and then
shoot,
you
I pushed the
square,
wrong
and then you do the
thing.
inside outside. But here you gotta
Inverse
do
tangent of
tangent.
2.
It's stupid.
Oh, yeah, I did, 1.1.
1.1.
You say it was 54, right?
That's theta.
Yeah.
We want to stay in radians. So this should be 1.107.
Oops.
There we go. 1 over the cosine of 1.107. That squared is that.
Cosine
270
1.107
It's
squared.
54
Oops. Delete.
radians per second.
Watch how fast the other way is.
Yeah, we'll do the other way and you'll see that it's probably easier.
54. Wow.
Because I don't even think you have to find theta, do you?
No, you don't.
You don't, yeah. Okay, so when I say the other way, Jeanette, go away. On this way, we took that as our equation and we just found the derivative straight up. And then plugged in all the crap and it was a lot of work. The other way would have been to take this, solve for theta first.
I think it's only easier that way because you already have your d theta
Yeah.
dt on your side, and your answer just is your answer.
Solve for theta first, so I'd have that. Now do the derivative.
But you see, I don't know the derivative.
Derivative of
plus
theta is
1.
just d theta
I mean, 1
dt.
over 1 plus x squared.
So now we have to know the derivative of inverse tangent.
1 over 1 plus x squared,
1 over 1 plus x squared.
which is y over x squared, and then the inside,
1 over 1 plus
y over
y
x.
over x squared times
The inside, quotient rule,
derivative of the inside. It's a quotient rule.
x dy,
X dy dx, dy
Rho d
dt.
minus
dx dt over x squared.
over x. But then, hey, once I got that, easy money now.
Oh, really?
I already know x and y, I know dy dt, I know all that stuff, so it's just plugging in stuff, and that looks easier than that by a little bit.
By a lot of it.
By a lot of it, actually, yeah. This is just 1 over 1 plus, let's see,
40 over 20
40 over
squared,
20,
100.
so 4.
Yep.
40 over 20 is 2, squared is 4, times, let's see, 20 times
Times 5.
5400.
Yep.
That's 0 over
400
400. 20 times 20 is 400.
You get 270 times
1/5.
1/5
Times 270.
equals 54.
54 radians per
Second.
hour.
It says, how?
You just put seconds on the other one.
It says radians per something.
I'm
says-
an hour.
It says per
Radians
second.
per-
Oh,
says
and radians per
parentheses.
second. Ooh, what's our answer in? It's good.
It's in
I like it.
our, no, it's in,
Well, we should look at the units of all the crap we just did. So what are the units of this? Y over x. What were y and x? Y over miles, x were miles. So we have miles over miles. This is unitless. That's the thing. It's okay.
That's a thing.
That's the thing. It's actually going to be in radians. Radians are unitless.
Your dy over dt
So
is
it-
miles per hour,
That's miles per hour, and that's miles.
so it's miles squared per hour? No, it's units per hour.
Miles times miles per hour.
so you have miles squared over miles per
That's what
hour.
I just.
Miles squared over.
Oh, but we're
Miles
dividing by
squared over-
miles squared, aren't we?
So you have units
So
per
you
hour.
just have units per. one
So
over
it's
one.
units per hour. So our answer is in radians per hour, so we need to convert it to radians per second.
Divided by
Nice.
something.
Divide by 60, divide by 60.
Yeah, I don't know.
So divide by 360.
The answer?
Yeah.
Divided by 300.
Right, or you could do
0.15.
radians per hour if you do it the official way. Time, there's 1 hour, there's 60 minutes, times, there's
6
1
minute is 60 hours.
1
In
minute,
seconds.
60 seconds.
1 minute, 60 seconds. So it's 54 over 360. We'll give it that. 0.15 radians per second. Hey, that was good. We didn't even, on these answers, I just left it in radians per hour. That was good. That was fun. See, this is fun to me because
We're all like,
I kind of have to think. I don't just automatically know the answer in my head. That's
That's fun.
it's really boring. Like every other class.
we all didn't take calculus 3 times.
You will though.
Yeah, thanks to you. I won't be here.
Dang it. I want to do my hair.
It depends on what time. Morning. I'm leaving probably in the afternoon. To
I'm going.
why were you going?
Quinceañera.
Is it quinceañera this weekend?
In Carmel.
Oh, okay.
Someone from Othello.
Ready for some more?
No.
I like these problems because we only do like 3 and it goes by fast. We get like,
Let's see. Day 2.
you said no, you don't know that.
Problem 3, 4, 5.
Yeah, actually, that
Is there a day 3? Bring the day 2.
Oh.
I don't.
Oh yeah.
I
there's day
wasn't meaning if we know them or not. I mean the time goes by fast.
What?
I said, I like doing these problems.
Also, like,
no,
I like that
though. Not that I get them. But I mean when you copy my Sure, but you do it.
More examples. Woo! That's all this is. Number 3.
Can you bring me some donuts for some motivation or something?
No.
You're like so excited and it's bothering you.
Tris kids aren't really doing the job. We have like a party or something. We're not taking the AP test.
Oh yeah, now we cannot wait till after May 4th.
You know you want
You know we had the best geometry parties. That tacos, nachos.
nacho bars, taco
That's
bars.
basically how I
Didn't
ate
we
the
have
second
those
one. I was
last
like
year?
this.
Yeah, we
Oh,
tried,
you did
we
pre-cal?
tried again last year. That was a pretty good party too.
No, I don't. Just taste it.
Not today. Or
Well,
tomorrow.
no.
Obviously.
I won't be here tomorrow.
Friday.
Mr.
Buck.
Yes.
Is it just gonna be us trying this no video?
Yeah, I'm not gonna make a video. You're gonna get the day 3 problems. This is day 2 still. That's the 3rd day.
On the 5th day, we'll still be on day 3.
A cylindrical tank radius.
I was going through my head.
A cylinder,
A cylindrical tank.
cylindrical.
Can you draw that? There he is.
And he's into sunglasses now too.
Cylindrical tank
For like $300.
with a radius of 6. Is filling with fluid at a rate of 108 pi cubic meters per second.
I know, you freaking yelled at me.
Watch me.
No, he walked through. I forget what it's called. I don't know if I
Really?
108 cubic feet per minute, is that what it was? Oh, 108 pi
Is this pi r squared times height? Is how you
cubic meters per second.
That's because they were.
How fast is the height increasing?
So what are we
They
trying
mean
to find?
the height of the water, not the height of the tank. It's not changing. Height of the water.
Maybe it's a
DW.
Those people.
That's it. That's all we got, folks.
Yesterday. It's bad about this.
What equation? What's our equation going to be? What are we going to write an equation?
Are you trying to find volume?
I'm trying to find the height of the water.
Find the changing, how fast the height of the water is changing. How fast it's like.
The
Can you
HTT.
change?
He's just smiling.
So what are we trying to find?
The HTT.
EHDT.
Wait, what's wrong with you?
So what's our equation going to be that we're going to use to figure this out?
The volume equation.
Volume equation of a cylinder.
Which is
Volume equals
How do you find area 2 pi r? 2 r pi?
2 pi r squared. 2 pi.
Your homework tonight,
pi r squared.
memorize the formulas for the area and perimeter of basic shapes.
I know everything but a cylinder and a circle.
A circle is pi r squared.
Okay, let me write this down.
Squared.
So it's pi r squared times the height. That's your volume of a cylinder.
Pi squared h. Oh, duh. You just did the circle times the height.
dv dt equals 2 pi r h. But
Okay,
Find the
derivative it up. Be careful though.
Which one's the constant?
Oh, yeah, good. Brenda's learning.
No, radius. The pi.
Like, are you doing the derivative with respect?
they're all constant. No, the height's
Oh,
not.
this one's changing. Isn't r constant?
So you just
Yeah.
have to
The
keep.
cylinder's not going to get bigger. So can't we just really put 36 pi times h?
Wait,
But h derivative is just 1. Are you changing that? You get me?
Oh, yeah, but it's
so
all of this.
Yeah.
oh dh dt is.
First of all, what's the derivative of the left side? Let's move left to right here. What's the derivative of v?
dv dt.
dv dt. What's the derivative of this side?
36 pi dh dt.
Yep. We know everything we need to know. Ooh, what's dv dt?
You don't.
They told us
108.
that it was filling at a rate of 108 pi cubic meters per second.
Go with 100.
That's the change in the volume
108 pi.
over time. So it's 108 pi equals 36 pi dh dt. Do a little division. And what is that, like 6? No,
No.
3.
3 pi?
Just 3.
Oh, you don't.
Oh, pi is
go
Pi is
one.
a cancel. Yeah. 3 units.
Equals dh dt.
No, it's
Meters.
3 centimeters or 3 cubic meters. Yeah.
Be meters per second.
Meters per second or meters?
Meters per second.
meters and meters.
'Cause this is meters cubed per second.